Hello student, this is the class for GLEAT 2018 exclusive program. In this class, we'll be dealing with the topics from the traffic control devices which are like as per the GATE approach. The topics which we'll be covering today or which is important for the GATE examinations are: number one, the first topic is under traffic control devices. The topic is traffic sign. Traffic sign. In traffic sign, what we have to study, what we will study is that I will provide you with the notes. In traffic sign, you have to just remember the shape of the particular sign, like stop sign is this, like this shape, it's octagonal shape, red in color, the border color, the color of the border, and the background color. You have to remember this. I will provide you the notes. उसमें से आपको जो देखेगा वो सारा याद कर ले जो मैं notes में लिखा हुआ है. ठीक है, उतना is important. There is no concept in that. You just have to remember that. The color and all that, the shape, which is like easy for you. One marks question generally पूछा जाता है. The next topic is the signal system. The signal system. In signal system, we have to study the most important method, that is Webster method for design. Webster method for design. Webster method says that in order to design a particular signal designing means what you have to do, you have to find the time of all the lights. Time of all the light means you have different color lights. You know that you have three different color lights. One is green, another is yellow, and after that it is red. You know that these are the three color lights which we have in our traffic signals. So this is yellow and this is red. So we have these three lights. In the Webster method or any system, what we have to do is that we have to design these light timings. We have to design the timing for these three lights. It means that what you have to do, you have to find the green time, you have to find the yellow time, then you have to find the red time. To add these time, when you will add these time, you will get the total cycle time. Cycle time. It means the cycle time means the total time, which is including the green time, yellow time, and the red time. Green, you know that green is for the movement. Green is for the movement. Green is for the movement. Yellow is for the clearance interval and red is for the stopping. It means that in the green time, the vehicle will be continuously moving. In the yellow time, the vehicle will be moving. But they will only move when they will allow to move. It means it's an extra timing. I'll tell you what actually exactly it is. In the red time, you know that the vehicle cannot move. So Webster says that in order to calculate the total cycle time, you first have to calculate the normal flows of traffic. Normal flows of traffic. Another is saturation flow of traffic. Normal and saturation flows of traffic. You have to find the normal flows and the saturation flow. Now, what is normal and saturation flow? Actually, in this case, you have to design a certain cycle timing for a particular road section. For that road section, what you have to do is that you have to measure the traffic volume. क्योंकि आपको जिसके लिए डिजाइन करना है, for that you have to measure the traffic volume. Let's say the traffic volume on two roads. We have two roads in the intersection like this and this, this and this. We have this is road A and this is road B. So this is the intersection. We have to design the cycle timings. Right? On road A, the normal flow traffic is NA. On road B, the normal flow traffic is NB. This is the design traffic. This is the design volume, which is the 30th highest orderly volume. This is the design volume. Now, this is the normal flow, which means normally road pe itna traffic hoga. The saturation flow means the maximum traffic. The maximum traffic, it means that this will be SA and SB. This will be the maximum traffic or the maximum amount of vehicle that can be present on those particular roads, which are the two roads on which the vehicle are moving. It means you will first calculate the normal, जो normal present होता है, next you will calculate the maximum amount of vehicle which can be present on those roads A and B. Remember one thing, you will calculate the number of vehicles per lane only. एक lane के लिए बात करना है. If there are three number of lanes, then you have to consider it for one lane, and then similarly you will divide or distribute the traffic for other two lane. वो हमें मतलब नहीं है, हमें एक single lane के लिए बात करनी है. अगर आपके पास तीन लेन दिया हुआ है तो आप नॉर्मल ट्रैफिक को, अगर they are provided you with the three lanes, then you will just divide that particular with three, so that you will get the volume of the single lane. Question में all these things will be provided to you. They will provide you with the normal and saturation flow. Everything they will provide you. What you have to calculate is that you have to calculate the cycle timing. To calculate the cycle timing, Webster says that there is a method, there is a formula which says that the optimum cycle time is equal to C naught, which is equal to 1.5 into L plus 5 divided by 1 minus Y. Now let's see this. What is L and Y? They will give you, they have asked you to calculate the cycle timing. They can ask you anything where L is equal to 2N plus R. N is the number of phase. Number of phase means the time which is allotted for a particular type of movement. For example, in our Indian system, we have two phases, green phase and this which is the yellow phase. So we have two phases जिसमें इन दोनों में movement हो रहा है. देखो green phase में क्या होता है? In green phase the vehicle will move with the full speed. Yellow phase में क्या होता है? Yellow phase, green और red के बीच का एक certain extra time interval होता है which you will allow for the vehicle who have crossed the intersection by mistake to cross the total intersection. जिन vehicle ने intersection को they have seen the intersection after crossing stopping side distance, like if they are at a distance of a stopping side distance from the intersection and then they have seen that they have a certain green light there. For example, let's take the example. ये आपके पास एक road है. This is your road. Now this is the stopping side distance. यहाँ पे green light है. This is the stopping side. It means that the vehicle which is present here, he has to start thinking and braking before this distance because he needs this much of distance to stop at this point. But if he will do the braking portion and the thinking portion, he will start thinking after crossing this particular point. That means that he needs this much of distance to stop. It means if he will start thinking from here, then he will stop somewhat here. And if in that particular time the signal changes from green to red, then he will have to pay the challan. It means that after green time, let's provide some extra time for those vehicles who are under the stopping side distance zone to cross the total intersection. So this is known as the total amber time or yellow time interval. So that's why we have two different phases. One is green phase, another is yellow phase, in which the vehicles will be moving. So these are the number of phases. This is the total red time loss. Red time. This is the total red time loss which is provided in the question. So you will be provided with the number of phases. You will be provided with the total red time loss. What you have to do is that you have to calculate the optimum cycle time. Then you calculate the optimum cycle time. You have to calculate the optimum cycle time. You have to use this particular ratio. In this, y is equal to ya plus yb. Now, what is ya and yb? Ya and yb are the ratio of the normal and saturation flow on both the roads. Ya is this. Yb is also, this is nb upon sb. You can see that saturation flow will always be greater than the normal flow. It means both of these values will be less than 1. And now what is y? Y is equal to ya plus ib. So what you will do, you will just measure the normal and saturation flow. It will be provided to you in the question. You have to find the ratio of that. And if you add those two things to get the value of y, then you have to calculate the total time L. This is total loss time. This is known as total loss time. You will calculate the total loss time, which is 2n plus r, and the number of phase. R is the total right time. You will just put here, you will get the total cycle time. So in Webster method, this question can only be asked, which is the calculation for the total optimum cycle time. To calculate the optimum cycle time, which is the cycle time for the green, yellow and red light, you have to use this particular method, which is known as Webster method. You have to first measure the normal and saturation flow per lane. You have to measure it for per lane. Single lane only, you have to measure it. Then you have to just find the ratio, add them and put them into this relation to get the value of cycle time, which is the cycle time for the design. So this is the signal system by Webster method. This is important for the examination. They can ask this question from this particular topic, but only in GATE. So this is important for GATE only. Now, after signal system, there is another topic which is rotary, island. Rotary island you must be knowing. Rotary island is a central raised island in which the vehicles are allowed to move automatically. This is somewhat like this. Here the vehicles are allowed to move automatically. There is no extra device which is used here. What you have to do is that you have to just enter this rotary intersection. You have to move clockwise. You have to move clockwise and clockwise and clockwise. This is a raised portion. The main problem with this rotary island is that it will require a large area. And the second problem is that if the pedestrian traffic is large, then it will be difficult for rotary to handle this traffic. IRC says that the maximum capacity of rotary should not be greater than 3000 vehicles per hour. It means that when you will design a rotary, which is the automatic traffic control system, you will require large area and the motor traffic should be. IRC also specified that the motor traffic should be at least greater than the 50% of the total traffic. It means अगर टोटल ट्रैफिक आपके पास 100 व्हीकल्स है तो आउट ऑफ दोस 100 व्हीकल्स कम से कम 60 व्हीकल होने चाहिए जिनमें मोटर लगा हुआ है. ऐसा नहीं साइकिल रिक्शा भी लेके चलेगा. नहीं, IRC recommends that in order to design a rotary, you have to consider this particular point in which it is specified that the total amount of traffic should be at least 50% of the motor traffic. मतलब motor traffic should be at least 50% of the total traffic. Then only you will design rotary. अगर 50% से कम है, अगर आपके रिक्शे बहुत ज्यादा है, साइकिल बहुत ज्यादा, then you will not design this rotary because this rotary will be problematic for those particular reason in which the pedestrian and non-motor traffic will be present. अभी समझो यहाँ पे कार जा रहा है, यहाँ पे पेडेस्ट्रियन आगे चलता हुआ कैसे जाएगा बेचारा, ये कोई मूव लाइक दिस, इसके साथ मूव करेगा नहीं, इसको इसके ऊपर चढ़ना पड़ेगा फिर जाएगा. इट मींस दैट फॉर अ पेडेस्ट्रियन इट विल बी डिफिकल्ट टू क्रॉस द रोड व्हेन द रोटरी इंटरसेक्शन विल बी प्रेजेंट. तो इन केस ऑफ रोटरी इंटरसेक्शन यू हैव टू मेक दीस थिंग्स इनटू माइंड, कीप दिस इनटू माइंड. तो रोटरी इंटरसेक्शन में इतना इंपॉर्टेंट है गेट के लिए, गेट पे ज्यादा पूछते नहीं है. इट इज बेसिकली इंपॉर्टेंट फॉर इंजीनियरिंग सर्विसेज कन्वेंशनल पॉइंट ऑफ व्यू. तो इंजीनियरिंग सर्विस लेक्चर आई विल प्रोवाइड यू विद द बेसिक्स ऑफ दैट. But in GATE examination, it is not in the proper syllabus. You cannot say that it's in the syllabus. So generally पूछा नहीं जाता. But I told you that if it is possible, then they can ask a basic question in that. एक चीज ध्यान रखना, रोटरी में जब भी एंट्री होती है, एंट्री के टाइम we used to increase the area. We try to increase the area. Why? If you increase the area, speed will be decreased. Speed decrease होता है जब vehicle entry करता है, decrease speed से entry करता है. And when it is allowed to exit करता है तो high speed से exit करता है. It means you will decrease the area. तो exit you'll decrease the area, but at the entry you'll increase the area. Yes, just to remember that in case of rotary. This is a basic lecture on the rotary intersection, which is like important for GATE. You can say that. So, and the signal designing. So just go through that. And you can just practice the previous year question. As Pandit signing off this particular short session. Thank you. Bye bye. Take care.